Hello, class. We are going to talk about predicting the range at 20 degrees now. Now, we presented some kinematic equations for you guys. I don't want to be too heavy, but I'm going to be heavy. And so where's our stuff? Where's our video? So we have our video here for physics download, and we have one that's going to be at 20 degrees, and then we have another one it's again at 20 degrees. And so we'll have two data sets here, and we're going to utilize this calculator twice. So and then we're just going to submit what we have. At least that's the plan. We might end up doing one. So the first thing that we want to do is, while you guys are downloading that, I'll just go ahead and download mine by just selecting on this cloud button. And I'll do the same thing for this one, as well as my calculator. You guys are not going to see all of this unless you choose to see it, and that's fine. You just choose it by selecting the links that are going to be at the top. I don't have them there right now because I'm actually producing new videos. I have videos there, but I'm producing new videos. So let's get out of this and let's go to paper. And we want to talk about theory just a little bit, because the theory is going to guide us. And even if I don't do this in class, I'm just going backwards. I'm going to do the practice, and then we'll do the theory. So I'm going to create ourselves a new space here. And let's just go ahead and call this predicting. All right. So I'll just say done. So I presented a couple of equations to you guys. Well, I want to present a couple of equations to you guys, either reiterating or, again, presenting. And so we have XF minus X initial. This is the displacement in the X direction. We normally refer to this as delta X. So you need an initial position from which you're going to measure. Then you need a final measure, final position. You don't have to measure from the initial position, but when it comes to displacement, this is the only thing that we're concerned with. We have our initial velocity that we are going to have to find out, and we have cosine of the angle theta times t plus 1/2 a sub x times t squared. So notice that everything is going to be in the x direction. Even this velocity, this initial velocity times cosine of theta, that's the velocity in the x direction, because this has to do with not only magnitude, but how much magnitude is going in the x direction. All right. We're also going to have YF minus Y initial, which is just the displacement in the Y direction. So we start off with our initial velocity, and our initial velocity is going to be multiplied by sine of theta. And you'll notice that sine of theta is just the Y component. When I say the Y component, the initial velocity times sine of theta is just the Y component of the initial velocity. That's it. Plus 1/2 AY times t squared. Okay? So this is the idea. We have a ball. It is launched. It has an initial velocity. We're not concerned about it having a force at this point. Let's just say in an ideal situation, there are no forces acting on this. The ball is going to have a trajectory. This trajectory looks something like this. Then the ball lands. Okay? At this position, we have some X initial and some Y initial, which means that they could be measured from some other location. All right, so, or they could be measured from that location. We could just say that this is our origin at the ball. That means that this would actually be 0, 0. Okay? And then we're going to have some x final minus, no, not minus, not minus, and you'll have some y final. And these are our ordered pairs. And again, they can be measured from this position. So you can measure your y final like so, and your x final like so.